Who would like to start us off? You can give us one. And
if you lose the one time pad.
Yep.
Screw.
Okay, good. This is very true, okay? The numbers that you're using, right? You absolutely must keep them. Because otherwise, you're in trouble. In fact, if you even lose a single page, right, all the other pages become worthless, right? Because we have to start at exactly the same spot and then progress, right? Yeah, that's right. If a single number gets removed, you're like, well, guess this is a waste, right? Okay, so can't be lost. I guess you could put that under the general heading of the security of the one-time pads, right? Okay, they must be kept secure. All right, another one. I think, Nikita, you had your hand up?
I think you just said this wrong bit. What if you run out of numbers on the pad?
Okay, that's not wrong. All right, so let's see if we can articulate this, right? And this is what I was trying to allude to when I held this up, okay? 5 columns, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rows. 5, 13, 65 characters. This whole page, all I can send is a 65 character message.
Not one word less, not one
That's exactly right. I need everything, right? So how would I say this? I guess there is a length limitation, right? There's a length limitation because the longer the message I want to send, I physically need more pages in my one-time pad, okay? And if I don't have enough pages, I just can't send it, right? And it has to be one-to-one. All right, length limitation can't be lost. Trish.
Doesn't provide message authentication.
Doesn't provide, okay. All right, I'm going to put a question mark on this. Can you elaborate a little bit about what that means? What can you explain about that? Or can you maybe give us an example of what you mean?
Or give us the website.
You've got it.
Or give us the website.
-1 point. Okay, all right. Someone else want to do something that can actually tell us what it means. Come on.
And then you have to go because there's a column and there's a row. If you actually go in the row.
Good, good. Okay, so I guess you could say it's error prone, right? Because you have to read this thing, and if something is just slightly off, if I just miss a character, right? Or if the person reading it back just misses a character, I guess you're kind of back in this boat, right? Where your data isn't going to be exactly the same. Okay, good. And another one.
It can take really long. It's a long message.
Yeah, okay, so I'll put that together here, right? Time consuming. Because that kind of is the same thing as it's error prone. You got to take a long time to do it carefully. All right. Yep.
I have spaces.
Okay. Now spaces is kind of a.
Can't you do it as 0?
Yeah, you could just leave it as a space. Or you could assign it some other character. Like I could make that my 27th letter in the alphabet,
But
and it
then
would
that
still
would
work.
screw the thing because everyone else would think that was 26 and then you'd be like, no, I made a space.
Aha. Okay. So that starts to get to my next one, which no one else has guessed yet, which is that. We have to agree, right? But not only do I have to agree, how did I start off this lesson? How did I make sure that the person who I'm giving this message to can decipher my message? And I had to walk over here and I had to physically give my duplicate copy of the one-time pad to the person I'm sending to, right? Now that's no problem when the person you're sending to is 2 meters away from you, okay? But I'm just gonna assume, usually, the whole point of encryption is you're sending things to people who are far away.
Email.
So therefore, the problem is the exchange of the one-time pads in the first place, right? Okay. What this assumes is I have to get it over to his physical location, right? And that process is not easy. What if I send it in the mail? Then someone else can get it. Or do I have to walk up to him, catch a plane, and hand it to him to make sure he gets it and he gets it intact? Okay. So that is a problematic part of it. Okay. Yep.
What about punctuation?
Yeah.
Okay, so I'm going to put together punctuation, spaces. It's all this kind of, that can be sort of mathematically dealt with if we have extra letters or those kinds of things. Or you could just ignore them, you know? Like telegrams, in the olden days when they sent messages, right? They would have to send messages like this. They would say, I have arrived, and then because they had no punctuation, they would say stop. And then they would just keep going, right? So that was the system they used. You can get away with it. Okay, Anesh, last one.
Okay, this is for the exchange.
Yep.
If you're gonna go to give it to them, why are you gonna bother making?
Yeah.
Exactly right. Exactly right. Okay. So I guess why would you do this? I suppose what this allows you to do is send more than one message. Okay, so we can exchange the one-time pads, and then I can leave, and I don't have to come to him again. We can just use out this system for the rest of them. Okay, but you're right.
You have to create a massive stack.
Okay, all right, last one. Yeah.
You could like code the code.
Okay, all right.
Yeah.
I think that's still an problem because then how do you agree on how the code is encoded?
Just do just make it obvious, like make it binary, like a what do you call it, like a Morse code.
In which case, then someone can then work out what our code
It's
is,
gonna
right?
take Morse code.
Well,
Like,
anyhow, all right. Let me give you the other ones that I thought of. Otherwise, we'll run out of time. Okay, because I want to keep going. All right. Sorry. They're like punctuation. There are ways to get away. Like you could just say one,
Yeah, can't you just, yeah.
which is fine.
Oh, yeah.
So yeah. Okay.
C-O-M-M.
So let's see. Can't be lost. It has to be kept completely secret, right? But I suppose that's the same as most kinds of ciphers, right? The one big weakness that we're missing, and actually is a critically important one because historically this is how one-time pads were broken, right? Is that the one-time pads, they must be completely, perfectly random. Now, what I mean by random is there's no way to predict based on some of the numbers what the next number will be, the next number will be, the next number will be. Now, what I did was, I'll tell you how I did this. The way I generated these numbers was I went into Excel and it has a random number function, okay? I said, spit me out a random number between 1 and 26, and then I just copied it all the way across, okay? Now, what you look at looks pretty random, okay? It looks pretty random. But the thing is, how does a computer come up with a random number? How does it do that, right? Where's it going to go? And the answer is it's going to turn to maths because that's all computers can do. But maths is not random. Maths is predictable. Even the things that look unpredictable, right? Like for example, if I wrote out this series of numbers to you, it kind of looks, it has the appearance of randomness, but you know it's not random. It's completely ordered. Right? So these are the digits of pi. It looks random, but it's not.
What is it?
So these digits, right, though they look random, depending on how I get them, they actually may be predictable. And one-time pads have been cracked in the past, historically, during wars, because people worked out, if you can work out a section of this, you can start to determine what's the rule, how did they generate these things, okay? And then you can work out what happens in the future, right? So they must be perfectly random, which is a lot harder than it sounds. Even you, if I ask you to put together a random list of numbers, okay, it's actually very difficult to do. You have to think of numbers, and actually there are statistical ways, just like with letter frequency, right, to determine if the series of numbers that you've given me was generated by a computer or if it was generated by a human.